Welcome to Icon Education. Here we are discussing NEET PYQ of physics, and last year we got two questions from this topic, work, power, energy. So here this is the first question. They have given two cars, that is A and B. So these are having kinetic energies. First let me take the data. So this is 100 joules and this is 225 joules. And after applying the brakes, they travel a distance. So this is 1000 meter and this is 1500 meter. Okay. Now what they are asking is, so what is the force ratio FA by FB? That is a force applied on the force applied by the brakes on the car. Okay. So if you want to find this FA and FB, you have to apply work energy theorem. So what is this work energy theorem? Work energy theorem. The amount of work done on a system will be converted in the form of either kinetic energy or potential energy. Here we are talking about the kinetic energy. So work done on the system A or car A, whatever it is, W by WB equal to, so this is the change in kinetic energy. So here we are having a Ka by Kb. And we know what is the work done. So work done is nothing but F into S. We can say FA SA by, and this is FB SB, which is nothing but Ka by Kb. Now they have already given that SA value and SB and Ka Kb also. Let me substitute and finally I will get FA by FB into SA. This is 1000 by 1500, just substitute, equal to, this is 100 joules by 225. Okay, so let me cancel this 100 and this 100 and here this cancel. Finally we got FA by FB equal to 150 by 225, so which is nothing but 2 by 3. So here the answer is this 2 by 3. Now let us go to the next question. So this is also quite interesting. So here this is a vertical circular motion concept. Now initially they have given a velocity v naught. So here the initial kinetic energy, sorry, right. So here they have given initial kinetic energy, that is, sorry, initial velocity, I'm sorry. Yes. So here they have given initial velocity v naught. So we can write the initial kinetic energy. So this is a initial kinetic energy half m v naught square. Okay. So you have given this initial velocity v naught. Now this is moving along a vertical circle like this, but they have given at the point P that becomes slack. So if you see this, that means what is the meaning of that? The tension becomes zero. So tension becomes zero, but still the particle is moving on a circular motion. That means the necessary centripetal force is supplied by the radial component of weight. That means, so here we have this, sorry, this is the mass m, this is a mg weight, okay. And if I take this resolution, so this is theta and this is a 90 minus theta, okay. So this is a 90 minus theta, then it will become, the radial component will become mg cos 90 minus theta, which is mg sin theta. I hope you understand, mg cos of 90 minus theta, so that will be mg sin theta. So here there is no other force, only mg sin theta is supplying the necessary centripetal force. It's very important. So here the centripetal force is supplied by the radial component, that is mg sin theta. Okay, so then we can write this mv square by, here the radius we can take it as the length of the pendulum, that L, equal to mg sin theta. So this m gets, okay, keep that as it is. So finally we can write mv square equal to mgl sin theta. So here we are talking about this final point. Actually this is the final and this is the initial. So this is the final point at P. Okay. So I can write kinetic energy final equal to half mv square, which is mgl sine theta by 2. Next we have to find one more thing, that is a potential energy at that final point. So again I am taking final point. So potential energy. So this is the final potential energy mgh. But if you observe carefully, so if you want to find a h from this initial position, so it will be L plus this one. Wait a minute. Yeah. So if you observe this is equal to L sine theta, and after that the next up to that bottom, that is actually L itself. So the total height is equal to Vf, here it is equal to mg into L plus L sine theta. Clear? So finally we can write this as potential energy final equal to mgl plus mgl sine theta. Okay. Now we got final kinetic energy and final potential energy. So, and initial potential energy, there is no initial potential energy gravitational, it is equal to 0. So now let us apply law of conservation of energy. If I apply law of conservation of energy, so that is initial energy equal to total initial energy equal to total final energy. So we can write this is half mv naught square equal to this final kinetic energy mgl by 2 sine theta plus mgl plus mgl sine theta. So if I simplify this, I will get half mv naught square equal to mgl plus 3 by 2 mgl sine theta. Cool. Now, so we can cancel this m on either side. So finally here we got v naught square equal to this 2gl plus 3gl sine theta, something like this. Okay. So once you got this v naught square, and already we got from here final kinetic energy, we got v square, gets cancelled, v square equal to gl sine theta. And what they are asking is the ratio, that is ratio of final velocity to the initial velocity. So I can find v by or v square by v naught square, which is gl sine theta by this 2gl plus 3gl sine theta. So you can cancel this gl, and finally we got v by v naught equal to sine theta by 2 plus 3 sine theta, of course whole power 1 by 2. Okay, so mathematically you may feel a little bit typical. Okay, so this is the ratio of final and initial velocities. Just this is the application of law of conservation of energy, nothing else. Just to find the initial kinetic energy and initial potential energy, which is a 0 in this case, potential energy, and find the final kinetic energy and final potential energy. Just apply law of conservation of energy. Okay, thank you, and we will meet again in the next week.